All right, welcome to the review video for Standard 5, Solving Systems Using Substitution and Elimination. Let's take a look at our first problem here. Oh, okay. So, notice that our method of solving this system is going to be substitution. So here's my system. Two equations, two variables, so we're good to go. My first equation says negative 6x plus 8y equals negative 18. And then my second equation says 3x equals y. So when I'm going to substitute, I want to look for variables that are already isolated. That's going to help because it makes a little bit less work. And sure enough, this y right here, right, that's already by itself. So what we can do is say, well, since 3x is equal to this y, we can replace the y in the other equation with 3x, right? So we're going to plug in that 3x for the y that's next to the 8 here. So let's do that. We've got negative 6x, that part stays the same, plus 8, and now I'm going to open parentheses. Anytime I'm substituting a value or an expression in, I want to put that inside parentheses. It is a good habit, and it especially helps you not drop negative signs. So y was equal to 3x, so that's what we're going to put in place of the y. And then it's still equal to negative 18. That doesn't change. Now we have one equation, but there's only one variable. So we can solve for x. We can find out what the value of that variable is. All right, one step at a time. Negative 6x plus, now we're going to say 8 times 3x, which will be 24x, is equal to negative 18. We'll combine like terms. These both have x's, so they're like terms. So we've got negative 6x plus 24x. That's going to become 18x, positive 18x. And that's equal to negative 18. Our last step in isolating x is to get one positive x by itself. To do that, I'm going to divide by the coefficient on x, which in this case is 18. So I'm going to divide by 18 on both sides of the equation. Anything divided by itself is 1. So 18 divided by 18 is 1. We're left with just the x by itself. And negative 18 divided by 18 is going to be negative 1, because a negative divided by a positive is a negative. Okay, so now we know what x is, but we're not done solving this system. We have to find what y is also. To do that, we plug our value that we found for x back in to either equation. You can do both to check, or if you're feeling confident, you can do one. I would recommend while you're learning, plug it into both just to be sure. So I'm going to pick this one to start with because it's a little bit simpler. So I'm going to rewrite the equation, but now instead of the x, I'm going to put in what I found for x, which is this negative 1. So again, that's going inside parentheses, and that is equal to y. When I simplify, 3 times negative 1 is negative 3. And right there, negative 3 is equal to y. So now it looks pretty sure that the solution to this system of equations is going to be negative 1, negative 3, right? Because we always write our coordinates x, then y. But to be sure, I'm going to check it. So I'm going to do the check by taking these values for x and y and plugging them into my other equation, into this equation, just to make sure that I get a true statement, a number equals itself. So I'm going to do my checking in green. I'll say -6 times the x value, which was -1, right? That's our x value, -1. Then I'm going to add 8 times our y value, which was -3. Finally, that should all be equal to -18. So again, I just replaced the x and the y in this equation with the values we found for x and y when we were solving. All right, so -6 times -1 is +6, plus 8 times -3, that's going to be -24. And does that equal -18? Well, 6 plus -24, or 6 minus 24, you could write it that way also, is in fact going to be -18. So our numbers check out. We have our solution to this system of equations. Okay, let's try another one. So once again, we're going to be using substitution. But this time, our expression is going to be a little more. There's going to be a little more to it. We're going to start in the same way as we did last time. We'll look at our equations. X equals -y minus 9. And 6x minus 5y equals 1. Well, there is already a variable isolated here, which is nice. That's really handy. That's this x right here. It's already by itself. But this time, instead of equaling a single term, it's equal to an expression, this -y minus 9. So I'm going to circle that because this expression, that whole expression, is what we're going to replace every x in our other equation with. So here's that x, right, next to the 6, and I'm going to plug this whole expression in right where that x is. When I do that, I'm definitely going to put that inside parentheses. So it looks like 6 times the quantity, -y minus 9, and we're going to close parentheses because this just said 6x, and now this is taking the place of x. We're substituting it in for x. The rest of the equation stays the same. -5y is equal to 1. Now, we're just going to follow order of operations, use our equation solving skills, and isolate one positive y. Because this 6 is multiplying by a quantity, there's more than one term inside those parentheses, I'm actually going to draw little arrows to remind myself to distribute that 6 correctly, that it's being multiplied by the -y and the -9, both of them. So 6 times -y is -6y. 6 times -9 is -54. And then this -5y equals 1, that all stays the same. It just tags along. Now we can combine like terms. So this -6y and this -5y, those are like terms because they have the same variable to the same power. So -6y and -5y together make -11y minus 54 equals 1, right? I'm changing one thing at a time. Now I want just my y's on one side of the equation and just numbers, constants, on the other. So I'm going to add 54 to both sides. Oops. And I get -11y is equal to 55. Okay, looking good. Last but not least, to isolate y and have one positive y, I'm going to divide by its coefficient. So the coefficient on y right now is -11. That's what I'm going to divide by. Both sides by -11. Well, negative 11 divided by negative 11 is 1. So that just leaves me with one positive y. And then this positive 55 divided by the negative 11, that is going to be negative 5. It's negative because the positive divided by the negative will give us a negative. And then 55 divided by 11 is 5. Okay, so this time we found y first. Now we still need to find x. I'm going to plug my y value in to this first equation because x is already isolated, so it's going to probably be a little less work to figure out what x is. It would totally work if I used this equation, but we can use that for our check. So we'll say x is equal to negative, and this time instead of a y, I'm going to write negative 5. Notice, this already had negative y, but then y is equal to negative 5. It's very important that you include both negative signs, right? This first one is from the original equation, and this one inside the parentheses with the 5 is because y was equal to negative 5. Then just minus 9, because that's the rest of our equation. Then we simplify. X is equal to a negative of a negative. Negative times a negative is a positive, so this will be positive 5 minus 9. Simplify. 5 minus 9 is, oops, got a little close there, negative 4. So now we are pretty sure our solution is negative 4, negative 5. And remember to be careful. Sometimes you're going to solve for y first, sometimes you're going to solve for x first, but when you write your solution, you have to write it as x comma y inside parentheses. All right, let's check that in green. I'm going to use this other equation just because. So I'll say 6 times x was equal to negative 4 minus 5 times y was equal to negative 5 is equal to 1. So let's see. 6 times negative 4 is negative 24. Negative 5 times negative 5 is positive 25. So I'm just going to make this a plus 25. And that all should still equal 1. Negative 24 plus 25 is in fact 1. So we get a true statement. We get 1 equals 1. So our solution checks out. Okay, so that substitution, take a moment, think to yourself, could I do that on my own? Was any part of that a little shaky? There are a lot of resources in Delta Math from previous assignments. You can always reach out to your teacher for additional practice. But take a moment and think, what do I need to do to make sure I'm really solid with this method?